Hello, welcome once again. As you can see again in Google, I put the wiring diagram for starting circuit for Toyota Highlander 2008. The images that were given were all these images, as you can see. Now, clicking on this one, as you can see over here in the picture, this is the most simplified image. Basically, just to go over it, and then we'll go over the Highlander, through the ignition switch that you turn, you apply power to something called the relay. I went over this a couple of times in the video, so you probably understand what a relay is. If not, look it back up on the channel. From the battery, this is the positive and this is the negative. The positive goes through a fuse, 15 amp fuse. It goes through, there are 4 terminals. These are called terminals, as these terminals. They are numbered. So from the battery to the fuse to the terminal 30, we apply power, 12 volts, as you can see. The other side of this will give 12 volts basically through the solenoid, activating the starter. Also, there's ignition switch applying power through this. You see 86 applying power to the relay. So there's 2 parts that control the relay. The ignition switch when you put in the start position, and also the battery voltage from here, 30 to 87, applying it to the solenoid, which will activate the starter and obviously engage the engine. Let's look at another image. This is the simplified version. Now, when you put all these in, you see you come up with different things. Connectors, as I went over yesterday. Another image, this one, that I thought was a little easier to understand. You have a problem. You can't start your car. Do you have a problem called a crank and no start, or do you have something called no crank, no start? If you have a problem called crank and no start, you'll hear the machine, like a gun, a machine gun. That's called a crank and no start. That could be a fuel or ignition coil. This means start means we don't hear anything. You might hear a click or something like that, but you don't even hear anything. Now, obviously, multiple people will go and say it's the battery problem. But let's say you already convince yourself it's not a battery problem. You're dealing with either ignition switch problem, fuses, relay, or starter. How do you develop the skill for this? Regardless of which this is for, the diagram. It could be for Toyota, it could be for Honda, it could be for a Chevy. It doesn't matter. The foundation, the basic concept is the same as I showed you in the previous one. This is the ignition switch. When we're talking about starting the car, we're talking about being in this position, ST2. You're going to follow the green color-coded wire. Now, from here, from the battery, this is the battery symbol. You go through here, okay? Now, you have 2 choices. You see this splice? You have 2 branches coming out. One going to something called the relay, which we just discussed. This relay is not ready to be activated. Why? Because this part of it has to be activated first. So we go through this branch, through the red wire, and this goes through the ignition switch. And then it will go through the green one. It will go through here and now through here. There's another branch, this branch to another connector, which is a connector. The most important part is this is the starter motor, okay? As I showed you before, the solenoid, the starter motor. There is a wire, a heavy gauge wire, that will let you have all the amps, deliver the amps to the starter that is needed. 400, 500 amps, whatever is needed. Okay? Now, that is based on the relay. Everything comes down to the relay. The relay has to be activated. When you think of a fuel pump problem, think relay. When you think of a starter motor, think of a relay. When you think of your lights coming on, think of relays. Everything is controlled by relays. Here is now, we're going over here. let's follow this. Let's make it as simplified as possible, regardless of the make and model of the vehicle. We have a problem. We can't start the car. We went through the battery. He seems okay. We went through the fuses. The fuses seems okay. What are we left with? Ignition switch or relay or an actual problem with the starter motor. Now, there's a computer involved also. In this photo, this image, you do not see no computer. Many people have emailed me and told me, you know what, this line over here, this is the control line going to a coil. This goes to the battery directly. If that's the case, if this is going through a wire, through the battery, controlling this, that means this will always be on. This relay will always be on. Why? Because this part of it, this power is coming from here, and this is going to ground. That means this coil is always activated. If this coil is always activated, that means what? That this load side, the contacts are closed, and therefore the starter motor is always activated. So it can't be that case. In this case that you just assumed, there is no starter ignition switch in the starter position in this case. So therefore we have to come to the realization that the starter, the ignition switch has to have some form of action. If you follow like we said, go to the green wire, through the fuse, through here, this has to go through a computer. The computer will give you 12 volts based on if you're in a start position. When you are in a start position, you get 12, then you get 12 volts. This is turned on. Then what happens? Then the other branch that I discussed before, current can flow through this one to the starter motor, activate the solenoid, and then we have that great cranking amps being activated to start the starter motor and the engine. Again, first we need the starter, the ignition switch, turn on this fuse, go to the computer wherever it's going to, and a computer says, I will give you 12 volts. Why? Because you are in the start position. You are in the start position. I will activate the relay. And from that, you can activate the starter motor. Once you let go into the switch, you are back in the run position, or in the ignition switch is IG. Then the computer says, you don't need me anymore. I will not activate this relay anymore. Now, you have a problem. I'll repeat again. The battery was good, the fuses were good, the fusible links were good, the grounds were good. How can I tell right away if the starter motor is good? Well, as I said before, let's jump this. You see this jumper? This is a jumper. We always jump this side. Never jump, this is called the coil. If I put this jumper across this, and this, guess what happens? I took the resistance out of the circuit. That means I'm going to demand high current, more high current than the circuit is designed for. What's the consequence? The consequence will be computer modules being destroyed or damaged, or anything else being damaged. Never ever, like I said before, don't jump this side. Jump this side. What will this do to me when I jump this side? When you jump this side from the battery, through the fuse, through another fuse, through this part of this relay, through this, at least it's going to tell you that the starter motor is working. At least it's going to tell you the grounds of the starter motor is working. It's going to tell you the battery is working for sure, even though you said before it was working. The heavy gauge wire is working. The fuses are good. These wires are good. That's what's going to tell you once you go and jump this. But you have to make sure to jump the right ones, like I said. You jumped it, you know current is flowing through this branch right here. What about this branch? That doesn't tell you that this is working, right? It doesn't tell you that. So, actually, when you jump this, you don't even have to go through the ignition switch. As you can see, you're jumping here and here. Current will flow through here and through here. You're not going through the ignition switch. So you don't know at this point if the ignition switch is still good. You don't know if this part of the relay is still good. You don't know if the computer is still good. But at least out of out of the equation, you took out the heavy one, the heavy component, which was the starter motor. You know the starter motor is working. If it would be a fuel pump, and you would jump the relay like I advised, you know at least the fuel pump is working, the grounds are working, back to the battery. How important is that? Well, you don't want to spend money on a starter motor if you know that it's good. And this will dictate or confirm that the starter motor, at least that part of the circuit, is good. Can there be a computer problem? Yes. Can there be an ignition switch problem? Yes. That's why I said, go over here, turn on the switch, measure 12 volts over here. If you measure 12 volts at this point, that means everything is good. The ignition switch, the computer, this is good. But that goes with practice and skill to understand how to measure that. That's why I made a video one time, how to measure 12 volts at that point. So both ways are acceptable to me. If you want to confirm confirm starter motor, you can jump it. Okay, I know I'm repeating the same point over and over and over again, but that's troubleshooting. That's the only way to do it. So that's the first case. Starter motor is good. All wires are good. I'm still left with this switch. Turn on the switch. Put a meter over here, a voltmeter, one to ground, one to here. If this comes on as 12 volts, I know at least that the computer is good and part of the relay is good. I know it's confusing, but like I said, I went over in a video. Please look to my channel, Joe Electronic Schematics for Auto. Whenever you need help with wiring diagrams, in the Google, right here, is the Google. Here's the Google. Okay, wiring diagram for Highlander 2008. Okay, let me go over this again with the pen. This is a heavy gauge wire. If I put a short across here, current can flow through this part and back to the starter motor. I just confirmed the starter motor is good. But I left out in the equation this, I left out this, the computer, I left out this, and I left out this to ground. So that's what's left out. That's why I say, put the starter ignition switch on, let everything be activated. If I get 12 volts over here, that means the starter motor is not good, or the wiring is not good, or the ground is not good, or this one is not good. Either one that you do, and I went over it several times in different videos. Like I said, go to my channel, Joe Electronic Schematics for Auto. You'll see how I explain that much clearer. Okay, so instead of 2000 Highlander, you could put Toyota Camry. 2008, you could put Chevy Trailblazer, whatever, Suburban, whatever you want, BMW, and the year. Many images will come up, okay, and you get to choose for it. So, as you can see, this is the image that comes up. Whatever you need, that's the image that's going to come up. If you need pin connectors, that's what's going to come up. Okay, so very, very helpful this is. Just go to Google, like I said, and it should help you. Again, this is electronics is just too technical. I wish it would be easy as mechanical. You know, just look for a leak, or look for you can look for rotors, bad rotors, and brakes, and PCV valves, or EGR valves, and all those things. But those are mechanical. This is electronics. Electronics cannot be taught as mechanical. It is not a visual. It is just either you have a knack for it, and you have to develop it. That's why it's so. This is an educational channel. It's difficult to teach it. I try my best. Hopefully, if you're confused, just leave comments. I'll go over it. Thanks for watching.